we're going to have a two-part series. The first part, which is what we're having today, would be an introduction into LogM. I'll answer the question, what is LogM? What does it do? Features and capabilities, and how it links your geophysical analysis with petrophysics and geology. Moving forward, like Justin said, in the next session, we talk more of your time alignment, fluid substitution, and your AVO gathers and your wedge model. We will be discussing those. For agenda for today, I'd like to give us some goals so you can keep the demo in perspective, at least give you an idea of what you're hoping to get out of this presentation. Based on that, this is my agenda. I'm looking to give you an introduction, answer that question, what is LogM Advanced Synthetic? I'm assuming quite a bit of you came in to find out the answer for that question. Not only that, but how does it fit into your workflow? The best way to set it up, its features. And then after I'm done talking, I'm going to give you a live demonstration, which is what I think is best. I mean, seeing is believing. You get a feel for what's going on and how the software actually does work with your workflow, and then I'll be more than happy to answer questions at the end of the session. Let's get going then. What is LogM Advanced Synthetic? Now, that's a good question. It's actually an industry-leading geophysical application. Not only does it let you interactively edit your well logs, but it lets you evaluate synthetic trace character response as well. So it gives you not only your regular everyday log interpretation environment, but also lets you do your seismic response as well. It's got a robust amount of tools that gives you the ability to analyze and understand your seismic response to a geological model. Now, with all of that in your arsenal, what we hope is that you can use that to dramatically improve your accuracy and minimize uncertainty when it comes to reservoir characterization and then identification of your pay and then how to exploit that. Now, how does it fit into your workflow? That's a good question. I'm going to come through both from a geology and a petrophysics as well as a geophysics point of view. So as that geology and petrophysics work together, they get that log, they build their cross-section, they do some mineralogy analysis, you determine your sand, porosity, gas saturation. You start to build in some petrophysics model in there. Using that petrophysics model to either compare your core results with your logs, you build curves. One of those curves you come up building is a shear wave velocity. You can also create curves to correct for bad data and missing data as well. With all of that, LogM gives you the ability to build seismic models. So in LogM, you can build a seismic model from that whole geology/petrophysics model you built. You can see what the seismic trace response look like. You can start doing things like layer thickness, you can start observing layer thickness and do what if scenarios in terms of fluid substitution and things like that. That is one way LogM would fit into your workflow. Now, coming in to your geophysics, you get that data, you stack the data, you now have your process data, and you want to do an interpretation on it. You're going to do an interpretation based on your field analogs, your response of your pay, the quality of the data, your knowledge of your geology. All of that is going to help you come to a decision that this reflector right here has some geological meaning, and this is what it means geologically. Now, all of that is good, and all of that is in time, but you would need to tie that to depth, and LogM is a beautiful environment for you to do all of that. So it gives you the interactive well tie to tie. The well is the hard fact, and you're going to try to tie that to your seismic. With that, it gives that Rigo trace some meaning. So LogM is the environment that lets you do all of that. And even the models that you've created earlier, you can compare them with your geophysics and at least give you some assurance moving forward that both parties are telling you the same story. Now, in terms of how we want you to set it up, Well Editor is the heart of the LogM module, and we would love you to run it in project mode. If you don't want, what it does is it lets you leverage the data from your project directly. If you choose not to and you have data from elsewhere, you're more than happy to bring them in. We will accommodate those, and we take in almost every format. Now, whatever you do in LogM is also available to be moved out to any other project you want to use it in, or you can just directly leverage that in our other geographics modules. We think for a beautiful workflow, seamless, efficient workflow, it works best moving things straight into our other geographics module because it minimizes the import, export, and everything goes seamlessly through. Now, key features in geographics, you're looking at not only an environment where you can do your well-log environment, you also have the ability to edit, print, and create seismic as well. You can do your lithology field track and things like that. We let you build your AVOs. You can do your AVA modeling. You can do wavelet extraction, fluid substitution, check shot. You can apply your check shots, and you can do some time alignment. So there's quite an array of things you can do in there, as well as building cross-section models. Now, for our demo for our workflow, what I'm going to do is I'm going to show you the LogM advanced synthetic structure. I'll show you how the geographics project structure works and show you how we plan to leverage what you have in your project in LogM. I'm going to take you through geophysics interpretation and size vision. I'm quickly just going to show you the interpretation, how it came about, different options in terms of getting there. And then we'll jump over to geology and petrophysics interpretation in our PRISM module. So you get to quickly see that. Once all of those interpretation has been done, we're going to interactively bring that in to LogM, and in LogM we're going to do some work with it. Now in that I'm going to actively just show you some of the features. This is an introduction. It's more or less a housewarming, so you can get a feel for what's in there and what you can achieve. And feel free at the end of the day to ask questions, and look forward to our next webinar when we're going to go more into detail. Now at this point, I'm going to switch over to the live demonstration. And I'm going to pull up in my screen is what we call the LogM window, and right beside it I'm going to pull up our Project Explorer. I'm going to keep both of them side by side while I talk. So this is the LogM Advanced Synthetic window. You can see the name written there, LogM Advanced Synthetic. And like I talked about, the well editor is the heart of your module. You have other options there in terms of bringing data in and in terms of switching between different project settings, and even doing turbosynthetics. So turbosynthetics would be if you wanted to do a whole lot of create a whole bunch of synthetic either right now or in the future. You can set those up on a timer and do that. Now this is our Project Explorer. All of your data and your interpretation goes into your Project Explorer. So right now it's almost like your Windows Explorer, and you get to see all of your data in there. These are different modules that we use. And you can see all of that. You can see some of that data in there. My maps are in there, my seismic interpretation, my seismic picks, attributes, your well header, well curves. All of that data is in that database. And once it's in there, you don't need to bring it out to send it to anybody. The geologist can access it, the geophysicist can access it, the petrophysicist guy can access it. So everybody has access to that data. So right now we're going to leverage all of that in our interpretation. So once we've done an interpretation, we wouldn't have to export or do any of that. We can quickly just take that part of the interpretation and use and leverage it moving forward. That allows you to use data from everybody in getting a clearer picture of your play. Now, like I promised, I'm going to come out of here and pull up a size vision interpretation. So this is our size vision module, and when you see off the back right now is you can see a map view, and in that map view what you're seeing is a horizon that's been picked, a top eye, and you can see the size. You can see the seismic survey as well as the wells in that region. You can see some wells are producing, some wells are dry. That's fine. This is the map view, and this is our cross-section view. Now, you have a lot of flexibility in terms of how you want to bring your interpretation in. This could be a case of you having done this interpretation elsewhere, or someone else did the interpretation, is handing it over to you. We let you import those. You can import those horizons as ASCII files, XYZ files. There's quite a large variety of options you have in terms of bringing these in. But what has happened right now is I got the survey in, and the geophysicist, based on his knowledge in the play, has gone ahead and he has picked certain things in this cross section. So he's picked that shallow marker horizon as a as a peak. He's picked that. And when you get to a horizon, you see how he names it out quite nicely. So you got it over there as the upper marker right there. You got the detrital horizon picked as a zero crossing. You got the Madison picked as a peak. So the geophysicist has gone in there and has done some work, and he's picked what he thinks are different horizons there, and he's thought about them as being part of a geological model. So he's done his job in that sense. This is all in time, and we have a well in this region, which you can see. You can see actually we have a couple of wells. So I'm going to pick one of the wells in there that has the curves that I need, and I'm going to do some geological analysis on it and petrophysics analysis, and we're going to try to tie the two from there. One thing that's nice about the geographics environment is our well base. I'm going to fire that up, and while that is coming, I'm going to show you the level of integration we have. So this well that we have there, I quickly want to start looking at it in terms of petrophysics analysis, and I can quickly say I want to see it in Prism, and voila, it pops up. So this is that well in my Prism, and I'm going to control what we're going to see. That way we see what we're interested in. Okay. So you can see off the back, I have done some geological analysis. You see the tops have been picked. So that's the lower Colorado. You see the detrital being picked. You see your Madison being picked. So some geologists, the back in Shale has been picked. The Talcott has been picked. So some geology has been done. And then I took it a step forward by doing some petrophysics analysis. So I've calculated my volume of clay. I've calculated my volume of oil, volume of water. I'm using an Archie interpretation in here. And geographic Prism lets you go ahead and do as much interpretation as you want. If you want to do any more analysis or curve generation, build more curves, you can always do that in our well editor. So you have quite an array of options to do that. You can also generate curves in LogM, but this is where you would comfortably do as much of your petrophysical analysis as you want. Generate the curves that you think you need to move forward in terms of your modeling. Now, once all of this has been done, I can save this, and it goes into the database, and that is available for me to work with in LogM. My tops, my curves, all of that becomes available. I'm going to minimize this, and right back here in our interpretation, I'm going to show you the well-based environment just quickly before I switch over to LogM. And this is our well-based environment, and you can quickly see information on those wells. So you can see the formations being picked by the geologist. You can see some of your velocity information if you have any, and you get this doesn't have it. You can quickly use filters to run what you need. So that's a good thing about the well-based environment. You can quickly QC things in every stage in the workflow. I can see what vector curves I have in terms of curves I have available. So all of that is really good in terms of knowing what you have to get your interpretation done. So at this point, I'm going to just open up the LogM well editor, and I'm going to right-click and just pick the LogM. That's the level of integration. You just quickly pick, and you go into the next module, and all the data you need is coming with you. It's asking me the number of traces I'm going to need. I'm going to ask for 26 traces. That will be 13 on the left of the cross-section, 13 to the right of it. And I'm going to bring all that in, and I'm going to fire up LogM. So that is your LogM well editor. And what you see on your screen right now is 13 seismic traces to the left, 13 seismic traces to the right, a synthetic that was being generated based on the curve that I have, my TVD corrected sonic, my gamma ray and my SP curve, and my rho B curve. That's what you're seeing on the screen. And what you can notice off the back is on your formation tops, you see that all of my geology comes in. So all the geology information on this well comes in. All of the tops have been picked by either the geologist or by an organization, whichever source you have, you can see all of that. I'm going to plot none, and I'm really only interested in what the geologist has done and set in formations. So I'm only going to pick those ones I really care about. So I'm going to pick that. I'm going to pick the back in shell. I'm going to pick the back in sand. I'm going to pick the Madison. I want the geologist pick. I trust my geologist. So I'm going to go with my geologist here. And let's see the detrital, and I'll do the Lower Colorado. I think that should be enough, and let's go ahead and hit OK. It cleans it up quite a bit. You can notice off the back that right now my synthetic and my seismic, my wells and my seismic is matching pretty well. If you notice these horizons came in from SeisVision. I'm just going to quickly show you. This is our SeisVision. You see the colors of the horizons, blue, orange. All of these colors match exactly what you see in your LogM, which is really nice. Now you can always right-click on that seismic trace and update horizon, and you can see exactly what came in your interpretation. So right now, your seismic picks and your seismic trace came in. The horizon picks also came in. So you have a feel of whatever you were picking in your seismic in determining your tides. Right now you see how the Detrital ties very nicely, Madison ties very nicely, back in shale not so much, the Talkeye pretty nicely. Now it's tying nicely because I have a check shot in this well that I have applied to get here, so it's looking very good. Now once we're in this environment, we can start doing a whole lot of things in terms of analysis, in terms of editing, conditioning. A lot of those you can start doing off the back. So what I'm going to do is I'm going to start with the curve. So you see in your curve, you have an array of options in terms of editing your curves. I mean, you can do it as a single curve, multi-curve mode. You can even start estimating curves for curves that you don't have. So based on different relationships, you can start doing your density from your sonic. I mean, all of that is going to be nice to do with if you have some kind of model or some kind of lab data to check it with. All of that would be nice, but you can do all of these interactively. AVO curves as well, you can do all of those. And not only do we let you edit your curves, you can also edit your seismic trace. So you can start talking about phase rotating your seismic traces, time shifting your seismic traces. So you get a lot of interaction with that. Now, when you move forward, you get also an interactive time depth conversion environment. So your sonic curve is what's being used, and you can pick what sonic curve you use for your time depth conversion, and you can interactively apply time depth pairs or check shots to it to correct it. So you can do it interactively, or you can do it in a more analytical environment. All of that is up to you. We give you all those tools to do your job, so you can either get the best option based on the conditions you have in the environment you have, and come up with an answer that helps you not only save time but improve your interpretation. Now I'm going to show you, just create a synthetic off the back. So this is our generate synthetic environment, and you get a choice of picking what sonic curve and what density curve you want to use, and you get the choice of what RC calculation method, and you can interactively apply what check shot you want in there. You can control the sample time, and what is really nice about it is the wavelet environment. You get an array of wavelet options, and if you've extracted a wavelet, you can go ahead and pick that as well. So I'm going to go ahead and pick a wavelet extraction. I've done a wavelet extraction on here, and I'm just going to quickly go pick that. I've done one demo files, and that's a wavelet. So I've done a wavelet extraction in this environment. I'm just going to pick it, and I'm going to say OK. And I'm going to put it right there. So what I've done is I have just quickly built a synthetic based on my sonic and my density curve. And I'm just going to come in here. I'm going to zoom in just a little bit so you can just see that. I might just I'm going to remove one of these. So let's do this just to clean up. What's nice about it is the environment is very interactive. You can quickly right-click and pick what you want. So I'm going to zoom, preview zoom, and let me just move this over there. Okay, that's fine. So what I'm going to really do right now is I'm going to try to do some editing options and give you just an idea of how your editing is interactive. I'm going to come in and say curve edit, and I'm going to try to clip a curve. Now, for right now, I'm going to clip let me clip the sonic curve, and we're going to see the effect of clipping the curve on your synthetic directly. So let's I'll keep close on that. Sorry, curve. I'm going to just clip, I'll clip the density instead. I think I see more of an effect there. So let's do that, and I'm going to zoom in. So I'm going to zoom into your synthetic and your density curve, okay? And it's so interactive. I can pick the depth of. I'm very interested in between the I'm interested in between the Madison and the Takai. That's the zone of interest I'm really interested in. And I'm trying to clip this density curve. Let's say I'm clipping it at. Let's say I'm clipping it to. Let's see. Let's say I'm clipping it 2.5, which and apply. You can see interactively my synthetic curve is being affected by this change. Now, this tells you that not only can you condition your curve, but you can see the effect of your conditioning on your synthetic as you move forward. I mean, you know that raw data sometimes needs to go through some kind of conditioning. The process you go through, the sequence you decide to use in conditioning is up to you. But what we're giving you is an environment where you can interactively see the effect of it, so you see the effect of your petrophysics conditioning on your synthetic trace. That's a very nice tool. I'm just going to undo that. That's undone, and I'm going to close that environment and go back to our previous zoom. Now, we've created this nice environment. We've created this nice synthetic. Right now, I have a check shot that got applied that makes it look good. I can also go ahead and remove that, and we'll just show you. I'd show you how interactive. I'm going to remove that check shot. And you see off the back now, your seismic and your synthetic don't tie anymore. There's not a tie between those. So I'm going to come in here, I'm going to do a time alignment. And what's nice about the time alignment is because I have my horizons for my seismic and I have my well tops for my wells, I can interactively see what's going on and try to create some relation. I mean, I can see some trends quickly, versus if I had none of those and just trying to tie it, versus trying to just do trace matching. So you see that this is my right before my detrital in my weld, and I think that this matches this beautiful trough right there, and I'm going to tie that there, and I'm going to hit apply. That's a pretty good tie, and what's nice is it gives you a check shot velocity, which is really nice. So you can see right there. You can see interactively what you're doing to your velocity as you're interactively working on your time depth pairs. What's nice about that is you can get to it creates a check shot for you based on what you've done, so you can apply it not only in this module but any other module you go to that does anything like this. You can also apply those corrections elsewhere. Now, not only can you do a simple depth shift, I can do a multi-point. I'm going to zoom in quite a little bit, so I can see a little better. So right now I see a little better. I can do a little bit of a multi-point. I mean, it ties pretty good in most places. A multi-point, an example would be, I would take my seismic there. Let's see. Let's see how they tie on there. So example with these tie pretty good. I'm just going to move this top down just a little bit. Right there. I'm going to move this peak on my synthetic. I'm going to move it up just. Oh, sorry. Okay, just cancel on that. So I'm just going to move those. Let's see, current time. Let's just move that peak just a little bit up. Pick that. Let's take what I was doing before, which was just moving this. Increase in time. So let's see, what is that doing? So I'm moving those in. Sorry, come back in again. Multi-point. Zoom out previous. I'll do a shift like we started. And what's really interesting about this is the tie is pretty good tie off the back just with a simple static shift. So I really don't have to touch it much. It's really me trying to mess with something that looks pretty good. That's really what's going on right now. So you see how closely they tie. The peaks are closely tied over there. I'm going to zoom in. No, zoom in a bit, which would be just this area right there. Pick that area right there. And I'm just going to leave it the way it is because it seems to be timed very well. Well, you have the options to not only do the static shift, but you can do a multi-point stretch and squeeze, which means you can pick different points and tie them, as well as an interval stretch and squeeze. You can pick an interval and stretch it out. That would be, those are options that you have available to you. What's nice about LogM is when you're trying to do something that's not realistic, which is what I was trying to do earlier, you see that it doesn't let you, it tries to keep to that to the physics behind it. So it's going to give you a bit of stops when it says, hey, what you're trying to do is not physically possible. So that's one of the good things about it. So it gives you a kicker. So you can't just go in and build a model that does something that doesn't exist off the bat. Now once we've done that, I'm going to go back and apply my check shot in again. So this is the check shot I had for the well. Now, I had done in previous exercise, I have built multiple check shots, and what we have is a check shot editor. So what you have is an environment where you can now do an intense work on your check shot and see how your check shot ties to your sonic. So you see the red curve is my check shot, and you see how the check shot, and you see the blue curve is my sonic curve. Now, we also have a drift curve that gives you a chance to do analysis on how the difference between your check shot velocity and your sonic curve. So you have all of that available to you. Now I'm going to select the check shot that I built earlier, which is just one I did on my own. So I'm going to pick that, which would be 10. I'll pick that up, and this is what I came up with. This is what with my interactive line ties. So I not only can see my interactive line ties, I can also come in and edit them if I need to, both by typing in or by moving it on the graph. So you have all of that option, and if you want to apply the correction, you can apply the correction to that sonic curve. So you can check shot correct your sonic curves here as well, and all of those options are available for you. So with all of this done, you've applied all of these onto your sonic curve. You feel a lot better between the tie between your well and your seismic now. And if you want to get a feel for how good that tie is, we have what we call the cross correlation graph. I'm going to do a synthetic to seismic, and right now I'm just going to pick a time zone, which is very interactive, so you can just quickly pick it on your. So I'm going to start. So I'm going to say start time, and I'm going to pick from over there and end time right there. This is the zone of interest, and off the back, my correlation. You see my correlation coefficient right there. It's pretty high. 0.951 is very good. I mean, that's really good, and that's because I have a check shot in there as well. And I used the wavelet that was extracted for the seismic, part of the reason you get that. But you also get the chance to not only do that, but you can start playing with your phase. So you see I'm switching the phase on these, and I can see the effect. Right now it's giving me a very bad effect. So right now, let's see, I'm going to rotate it all the way. So I think right there what I had earlier was the best, about 0.951. So you see, you get a feel that you can get an idea of how accurate your tie is. Now, with all of this done, what you want to do next is up to you. We can take this synthetic and we can take it right back into size vision. So I can go view my synthetic in size vision, and I'm going to do that right away. And you can see, so this is my size vision, and I'm going to go to that well, and I'm going to select the synthetic I just generated. And you can see that synthetic in my size vision right there, bam, and you can see the strong correlation now. Now when you call this horizon the detrital, you feel very comfortable about it because, hey, guess what? It tied with my size synthetic. When you call that you call this a back-end shell, you feel comfortable about it. Or when you talk about the back-end sign as well, the Takai formation, it gives you a tie that tells you that, hey, this is what this is in time, this is what it is in depth. Now you've increased your accuracy, and now you can minimize your risk in terms of moving forward. Now there's a lot of other things you can do. We can go ahead and plot. So for our presentation purposes, I can plot this environment that I have, which is what you see right here. Is I just created a plot of that data that I have. This is good for presentation purposes, and even if you're not doing presentation and you want to take this data elsewhere, you have the ability to export your synthetic as a sequoia ASCII, and you can do you can get in your with your deviated data, you can get this data in, and you can do things like your TVD correction. We can do some math toolkit calculations. Like I said earlier, you can do some wavelet extraction and some fluid substitution with the Beal-Gossman relationship. So you get an array of things you can do here, and once you've done that, you can save it right back to the project, and it's available for the next person to use. And what you have here has given is letting the geophysicists know that, hey, what I have, this is what it means in geology, and this is how it ties to my seismic. And it gives him a better confidence when it comes to picking his prospects and how he wants to exploit it. So at this point, I have gone through and I have shown you how geographics is set up with LogM. We got all of our data. We went through a seismic interpretation. From there, we looked at a geology and petrophysics analysis on our well. We got our curves and our tops, and then we interactively took our interpretation from SeisVision as well as from our geology, and we brought all of them into LogM, and we did not only an interactive well tie, but we also created a synthetic. And after we've done that, we've taken that synthetic back to our geophysical environment, so that we can use it, leverage it in making better decisions in terms of our time depth pair, and then evaluating our pay and what we use to pick our pay response. And once you've done that, you have export options as well as plotting options.